Hello everybody, welcome to chapter 8.2 part 1, Logical Arguments. In the previous section we had the example where Fluffy is a cat, and the diagram here shows Fluffy the cat and Fluffy must be an animal. We do not want to bring in any previous knowledge or anything else, just what we're told about Fluffy. So we can write a conclusion of a logical argument. So we can write this conclusion as, meaning we can take this diagram and conclude something about it. So we can use our Euler diagram to write a logical argument and then come to a conclusion about it. So let's see. We have all cats are animals and Fluffy is a cat. And the first one, all cats are animals, we call premise 1. And Fluffy is a cat, we call premise 2. And the first two lines of the arguments of these premises are things that we take to be true. The last line here is the conclusion. And as you see, it's not part of the diagram. We just use the diagram to analyze and find a conclusion. Call this particular type of argument valid because it turns out that Fluffy the cat, is only in one place. But what would we do if the argument is not valid? Well, let's try a slightly different set of premises and conclusion. We have all cats are animals. Dan is an animal, therefore Dan is a cat. Well, Dan is an animal. All cats are animals. Okay, Dan is an animal. Well, Dan can be an animal cat, or Dan can be some other kind of animal like a human being. So we can put the D for Dan in both places. We can put him either as an animal cat, which is fine, or we can put him as just an animal. It's not particular what kind of animal. He could be a cat. He may not be a cat. We're not given explicitly what kind of animal he is. The conclusion that we're given, therefore Dan is a cat. This is not a valid argument because we can place the D for Dan in two different places, and that would mean that this is not a valid argument. Looking at example 1, we're going to decide which conclusion is valid. So let's see. We have a situation, premise 1, all squares are four-sided. M is four-sided, therefore M is a square. And here we have all squares are four-sided. X is a square, therefore X is four-sided. We're going to use the premises to make our Euler diagram, and then we're going to place our M or our X to see if the conclusion is valid or not. So let's try this. Now remember, we only use the premises to make the diagram, not the conclusion. Here, let's do it. So here we draw our Euler diagram, and here we have our two arguments with their premises. So let's look at how we do this. We have, in the larger circle, we have four-sided things, because that's more general, and squares are a particular kind of four-sided thing. So remember, this is a four-sided thing, but it's not a square, but squares, again, are a particular kind of four-sided thing. Let's look at the first premise in this one. All squares are four-sided here, and M is four-sided. So that means M is four-sided, so it may be a square. That's true. And it may not be a square, but still it's four-sided. So it could be either this guy over here, a parallelogram, or a trapezoid, or M could be a square, which is still four-sided. It's sort of not clear whether M should fall only here or only here. Well, let's look at the other argument. All squares are four-sided. Okay, that's all right. And X is a square. So that means X can only be here. It turns out that our conclusion, the only one that is true is this one because it falls in one place in the Euler diagram, and this one is not valid because M falls in two places. So X falls in one place. That means this is valid, and m falls in two places, that means this argument is not valid. Thank you very much. I hope you enjoyed this video. Be well, take care, and goodbye for now.